So the next question is, we derive an expression for constant temperature, uniform temperature, uniform flux for laminar flow. What happens if you have a non-circular cross-sectional area? So then we have this table. So we calculate the hydraulic diameter 4 times cross-sectional area divided by perimeter. So you basically calculate, you define your Nusselt number in terms of this hydraulic diameter, and depending on the aspect ratio, you read this constant and calculate H from here. Okay? So the next situation is, what happens if you have an annular flow? Let's say we have a solid core, and then flow is between this core and the shell. And how do you calculate the Nusselt number? So as you can imagine, so we have two diameters here, inner diameter, outer diameter. So you take the ratio of the inner diameter and outer diameter, and you read, you have two Nusselt number. One is inside, one is outside. So inner side and outer side. So the Nusselt number for inner side and Nusselt number for outer side. These are tabulated. These are tabulated. So in here we assume one surface is insulated, the other surface is at constant temperature. One is insulated, the other is at constant temperature. So that means the Nusselt number is tabulated, and you can read it directly from here. So this is for constant surface. One surface is at constant surface temperature. If you have uniform heat flux from both surfaces, so then we have to use slightly different equation. Again, we calculate di over the outer. That's the first step. So then we calculate inner Nusselt number, inner, and outer Nusselt number. Inner Nusselt number is function of new Nusselt number II, and outer Nusselt number is a function of Nusselt number outer OO. So here, based on the diameter ratio, you read these values here. You read these here from here, and you also read theta values here, and then you calculate inner and outer Nusselt number. Okay, so again, the main difference between this table and previous table, in this one we assume uniform heat flux from both surfaces. In the previous one, you assume one surface is insulated, the other is at constant temperature. Usually they give fairly close numbers, so most likely from the problem statement you will know which one is the case.